Okay, so this is going to be a short video going over writing trig functions given a graph. I might suggest you, because I printed off the notes for you, I might suggest that you try each problem yourself or try it with a neighbor, a group, and then see what you can figure out and then watch the video over each problem. Maybe like one problem at a time, but anyway. So this first one, I've got a sine wave, and I'm supposed to somehow make it meet this criteria, right? So I'm going to go ahead and write y equals, leave some space, sine, open parentheses x. And so if you remember where we're going to put all our transformations, here's any kind of amplitude, here's the horizontal stretch or compression, here's the horizontal shift, left or right, the phase shift, and then the up and down, right? So one of the easy things to do is to figure out, like, where is the top and where's the bottom, where's the min and where's the max. So this is at -1 and this is at 7. That's a total distance of 8, which means 4 down or 4 up would be the midline, which puts me at 30. So I know I'm going up 30. And then I also know that my amplitude is 4. Okay, I need to figure out my period. So if I look at this wave, what I want to do is I want to graph the midline, and I want to find where I cross the midline. I cross the midline here, which looks like pi, and here, which looks like 9 pi. I also cross it here, which is 5 pi. But if I think about an entire wave, it looks like this would be an entire wave, right? So I'm looking at this and I think, okay, well that distance is 8 pi, so my period is 8 pi. And just remember the formula for period is 2 pi divided by b. So if 2 pi divided by b equals 8 pi, then 2 pi divided by 8 pi equals b. And so then I get that b equals 1/4. So I'm going to put 1/4 right there. Okay, the period is 8 pi. So if I think about like period being, you know, the first tick mark, the second tick mark, the third, well, actually that's usually the 0. But anyway, yeah, so 0, or the 1, 2, 3, 4, the 5th tick mark, because you always have like the starting point and then the end, right? Well, then that looks like to me that this right here normally, so I'm going to draw a little sine wave. It looks like I moved over a half. Like if I had moved over 2 pi, because see this is 4 pi, 6 pi, and 8 pi. If I had moved over a quarter of the period, then I would be starting at 2 pi, but instead I'm starting at pi. So I think I'm just going to say I'm moving to the right pi. So I'm going to say minus pi in the interior, which means my final answer could be 4 sine of x divided by 4 minus pi divided by 4 plus 3 after distributing the 1/4. Okay? Now, let me think of a different option. Okay? Or y equals sine. Now there's some things that will not change. That will not change is the amplitude and the vertical shift. So this is up 3 with an amplitude of 4. But I could think of it as a negative sine wave if I start here, right? So if I thought of it as a negative sine wave, then I could say I moved the negative sine wave to the right 5 pi. So the period also doesn't change. So that's still a 1/4. But instead of saying to the left, or to the right pi, I could say a negative sine wave to the right 5 pi. So then I could say minus 5 pi. And so y equals -4 sine of x divided by 4 minus 5 pi over 4 plus 3 would also work. Okay? So these are just options. Obviously, we're not all going to come up with the same answers, but it'll be interesting to see what we come up with. Okay. The second one is going to be a secant wave. So I'm going to write y equals secant x, and then, okay. So I'm looking at this, and I see that it goes up a half and down to -5 halves, or so 0.5 and -2.5. That distance is 3, so that means 1.5 is the midline. Well, 1.5 away. So that means I think -1 is the vertical shift. So I'm going to go down 1 on the outside. It also means that the amplitude, if you will, for the cosine wave, if I were to sketch that, would be 1.5, so I'm going to put 3/2 right there. Okay. I need to figure out the length of the period, so regardless of secant or cosecant, I don't really care. I'm just looking for like a complete period, which is one of these and one of those, and it looks like if I have a vertical asymptote here, then the next one would be here, and that's at pi over 2. Obviously we would have one there. But it looks like pi over 2 from 0 to pi over 2 creates one wave. So I'm going to say the period is pi over 2, which means for secant, the period formula is 2 pi divided by b equals pi over 2, or 2 pi divided by the period equals b. Dividing by pi over 2 is the same thing as multiplying by 2 over pi. Pi simplify out, and so I'm getting that b is 4. So I'm going to put a 4 right there. So the last part is just figuring out what kind of phase shift I have. Right off the bat, it kind of looks like a cosecant wave just because it looks like I could easily put a sine wave right there. So I'm going to think about my regular cosine wave with the same amplitude, okay? I could draw it out to the side, I could draw it on here, it's whatever you want to do. So if I thought of that as my amplitude line, a normal cosine wave would be here, here, minimum, there, and there, if that was my period, right? But the maximum is actually over here, or you could see it as over there. So I could see it as either going to the right, well, let's see, if that's pi over 4, then that's pi over 8. So I could see it as either going to the right, pi over 8, or going to the left, if that's 1/8, 2/8, 3/8, going to the left, 3/8. So either way you write it, whichever one you put in here, you could put plus pi over 8, or you could put sorry, that's backwards, minus pi over 8, or x plus 3 pi over 8. And either one of those will give you a correct answer. Okay, so if I do this one, then I'll say y equals 3/2 secant of 4x. If I distribute the 4, I'm left with minus pi over 2 minus 1. And if I use that one, then I've got y equals 3/2 secant of 4x plus 3 pi over 2 minus 1. Either one of those is going to give me the same graph. So I was just looking at remembering that my secant normally hits a minimum, or yeah, when cosine has a maximum. And so I was like, well, let me just move this to the right here, or move it to the left there. And either way, there we go. All right, one more. Tangent, okay, so when I think about tangent, I gotta remind myself that it's normally a vertical asymptote on either side of the y-axis, with half the period being here and the other half being there. This obviously has a vertical asymptote here and a vertical asymptote, I'm thinking at 3 pi. Yeah, see how much space is between that and that and that and that? So I'm pretty sure that's going to happen at there. Which tells me right off the bat the period is 3 pi. Okay, so if I start out my function, tangent, and myself no space, whatever. X goes, okay. As far as the center of the wave goes, that looks pretty symmetrical above and below the x-axis, so I'm thinking that that is my center line, which means I don't have anything. I'm going to put plus 0 just as a reminder that that's all I have. Now, the next thing to do is to figure out when it equals, let's see, would be a good way to say that. Okay, here's how we do it. Normally a tangent wave does this, right? So the easiest way to figure out your amplitude, or your vertical stretch or compression, is to go over half of your, or a quarter of your period, and go up, and that's where it is, or in this case, down. So if that's the center of my wave, then if I go over a quarter, which is right here, and right here, so if my period is 3 pi, then this is 3/2 pi, and then this is 3/4 pi, and 3/4, 6/4, and 9/4 pi, right here. Then if I go down, it looks like I'm going down 2, and if I go left and up, it looks like I'm going up 2, so I'm thinking that the number out front is 2. Alright, period is pi divided by b, but just as a reminder, I mean, pi divided by b equals the period is the same thing as saying pi divided by the period equals b. So I'm going to say pi divided by the period 3 pi equals b. B is 1/3. All right, so normally I have a tangent wave and it goes from bottom to top. This is coming from top to bottom, which, okay, that just means I have a negative out front, which I did not leave myself enough space for. Okay. And then, where's the vertical asymptote? Because that's an easy one to do. So this vertical asymptote, it looks like I could make it be this one. So it looks like it shifted to the right, to the y-axis. So if normally it was at 3 pi over 2, so if I think about 3 pi over 2 being the half on a normal tangent, right? Then I could say either I move this vertical asymptote to the right 3 pi over 2, or I could think of it as moving this vertical asymptote to the left 3 pi over 2. Whichever way you'd like to say it. So I could either put plus 3 pi over 2 or minus 3 pi over 2. It's just whichever way you see it. For me, it makes sense to go, this is 3 pi over 2, and then this is negative, and this is positive 3 pi over 2 normally. But now this is at 0, and then this is at 3 pi. So it's here and here. Or backwards, whichever one you see. So I guess I could say that my final answer is -2 tangent of x divided by 3, or 1/3 x. I'll go plus, and then that is going to be pi over 2. Or y equals -2 tangent of x divided by 3 minus pi over 2 when I distribute the 1/3. And okay, there we go. Hopefully that helps.